In today's video, I am going to discuss about the graphical proof of equation of motion. The equations like v equal to u plus at, v square equal to u square plus 2as, s equal to ut plus half at square will be proved graphically. And to go through the process, we have to introduce the concept of equation of straight line as well as the intercept and the slope. Basically, the equation of a straight line is represented by y equal to mx plus c. The equation of straight line is represented by y equal to mx plus c, where m is the slope, it can be written as tan theta also, where theta is the angle made by the straight line with the horizontal axis. In this case, we will consider x-axis as the horizontal axis and y-axis as the vertical axis. And C is the intercept. Here, intercept is the point of intersection at which the line will pass through the y-axis. The graph will look like this. Horizontal axis is x-axis and the vertical axis is y. As the equation is y equal to mx plus c, it will look like this. This portion is the intercept plus c. This is the origin, and theta is the angle made by the horizontal axis and the straight line. Here the horizontal axis being x, so it can be parallelly shift like this, and this is the straight line, so it will be the theta. In this case, tan theta will be the slope. If we consider a triangle ABC, then tan theta will be equal to perpendicular by base. If this is theta, then this will be theta also. So it is the perpendicular and it is the base. So tan theta will be equal to BC by AB. That is, tan theta means slope is equal to change along the y-axis by change along the x-axis. As BC represents the changes of y-axis and AB represents the changes of the x-axis. So tan theta is equal to slope, that is delta y by delta x. Now, if we consider a particle which is moving with uniform acceleration, then it will be represented as if this is being velocity and this is being the time. So a particle moving with uniform acceleration will be represented like this. If this is theta, then at every point of the line, theta will be same. As theta is same everywhere, which is a clear indication that tan theta or m or slope will be constant throughout the line. So tan theta being constant, we have to show that tan theta is actually the acceleration. We all know acceleration is equal to change in velocity by change in time. Now consider the angle being theta and the triangle being ABC. If this is theta, then it will be theta also. So tan theta is equal to change of the y-axis, that is BC, by change of the x-axis, that is AB. Here BC is the change of the velocity and AB represents a change of the time. So it is actually change of the velocity by change of the time. That is a clear indication that tan theta is nothing but the slope, that is acceleration. So tan theta is equal to acceleration, which is represented by generally acceleration small a. Now, if a particle is starting its motion with an initial velocity u, then the graph will look like this. Initial velocity means u. Okay. So the particle is moving with an uniform acceleration a and with an initial velocity u, and it looks like the given graphical representation. Consider this point to be A, this to be B, this point to be C, and this to be D, and it is theta. So tan theta is equal to slope is equal to perpendicular by base, that is BC by AC. Tan theta is equal to m is equal to BC can be written as BD minus CD. BC can be written as BD minus CD by AC. Now, u is the primary or initial velocity, and after having an interval small t, the velocity becomes v. Initially at t equal to 0, the velocity is u, and after an interval small time t, it becomes v. So from figure, tan theta will be m equal to v minus u by t, which is equal to change in velocity by time. That means it is nothing but the acceleration. So in this graphical representation of the motion, the slope represents the acceleration. Now, if we consider the equation of straight line, which is equal to y equal to mx plus c, then along the y-axis it represents the velocity v, and along the x-axis it represents the time. So the vertical axis being velocity, put along the y-axis v, m being the slope, that is acceleration. So putting a in place of m, and along the x-axis it is representing the time. So put t in place of x, and c is the intercept. Here the intercept being u, put u in place of the c. So the equation becomes v equal to u plus at. That means a particle starting with an initial velocity u with an and going through an uniform acceleration will have a velocity v after an interval small time t. V being the final velocity, u being the initial velocity, a is the acceleration, and t is the time.